Assalamu alaikum friends, welcome to my YouTube channel Civil Ideas. So today we'll discuss about the reinforced concrete structural framing system. You may have seen the framing of the structure of building structure, and that you have seen the slab system. Normally you have seen the beams and columns, but there's about 7 to 8 types normally followed in the world of the system that normally transfer the load to the foundation from the slab to the foundation. So they have used somewhere they are used beams, and some there's only slab, and some the frame you may have seen the only the capitals above the column. So we will discuss all these types in this video. So now is the first type is the flat plate system. Flat plate system mean there is only a slab and the of uniform thickness. There is no beams, only periphery beams. So we provide only the periphery beams around the structure, not and the mat. So only the mat, only this column supported the slab. So the slab has the uniform thickness, and the column to column span you may provide it in this type of system has 15 to 25 feet, and it is normally constructed for normal live loads. And the failure criteria is normally is a punching shear. So it normally fails due to a punching shear. So this is the punching shear, this is the slab, and this is the column, and it punch or that slab. So this is the punching failure criteria that is normally occur in this type of slab. So this is short about flat plate. Now we'll discuss about the second type, and I have put all the details in my article about this structural frame system. You check the link in the description. So this is the second type of slab system. It is called flat slab system, and the first one was flat plate system. This is the flat slab system. So the only difference is it is provided with a column capital. This is the column capital, and then near the slab the columns head is provided normally thick near the slab. So this is the column capital, and there is no beam. So column to column span normally this is 15 to 20 to 25 feet. So this is the normal and it is designed for normal live loads, and the failure criteria is the same as the first slab. Flat plate is like a punching shear. So is this slab failed due to punching shear. So this is the second type of slab. Now we'll discuss about the third. So the third types of framing system is beam supported slab system. And this type of system, beams are provided in both direction or maybe in one direction. So this is the sketch. You can see this is the beams and this is the columns, beams column system. So this is the beams and column system. It may be provided only in one direction or in two direction, depends upon the loads and the structural design. And this type of system, beams and provided in both directions, span up to 30 feet. You may have provided a span length between column to column of up to 30 feet, and it is designed for the intermediate to heavy loads. And the deflection criteria and the failure criteria in this type of system may be due to deflection of beams and column cracks or buckling. So this is the third types. So the four types of structural framing system is a beams and girder slab system, and in that type of system beams and girders are provided. It is normally for load spans beyond 30 feet, and it is designed for heavy loads. So in this type of system girders are provided along the length or in any direction, and then beams are placed on that girder closely spaced. The beams are closely spaced here, and the girders are provided at large span but at depth where it is deep than the beam. So the normal criteria of failure is deflection of beams and column cracks, buckling, etc. So this type of the step system are designed for heavy loads. So the fifth and sixth type of slab system is one-way joist slab system and two-way joist slab system. And this type of system, the girders and one-way joist slab system, the girders are provided at the ends, and the joist or small cross section of beams are provided are placed on that girder in one direction. Like this is the girders, and this transfer direction the joist are placed at smaller span. So this is the joist and one direction, and it is normally designed for intermediate to heavy loads, and the span length is between 30 to 50 feet. And two-way joist slab system, it is the same as first the one-way joist slab system, but the joists are placed in body direction. Like this is the girder provided at all the direction. This is the girders, and the joists are placed in the both direction, x and y. So this is the, and span more than it can provide for span more than 50 feet, and it is normally designed for heavy loads. It is much stronger than the one-way joist slab system, and it is also called waffle slab. So this is the fifth and sixth type of slab system. So the seventh type of slab system is composite slab system. In this type of slab system, the slab is normal RCC element, but the beams are provided are only a structural steel member, or the structural steel is encased in the concrete. So this type of slab system is a composite because the structural steel beam is encased in the concrete. So it is normally designed for normal loads, and the span up to 10 feet. And the last one is pre-stressed slab system. It can be a pre-tension or post-tension. The columns and beams are normal RCC, and it is designed for large span for heavy loads. And in this type of slab system, the slab is normal RCC, and the conduits are passed in the slab, and that conduit the strands were strands or the steels of high strength, and this is passed in the conduits, and that is stretched up to certain level. In pre-tension process, the strands are stretched up to a certain value according to the designer mentioned in the drawing. And in the post-tension way, the strands are stretched after the concrete.